Calculus, we're going to start today by looking at trig functions, and I'm hoping that yesterday you did an investigation into those. If we did not get to that, then I apologize, and this is a spoiler alert. But if you have the function y equals sine x, then what I was hoping you saw yesterday was that its derivative is cos x, which is very cool. If you have the function cos x, its derivative is negative sine x. So let's use those in a few examples. If I have y equals sine squared x, I could consider that as sine x squared. Remember, they are careful with that notation. So if I want the derivative, I have a sine x within a power, so I would bring down the exponent, reduce it by 1. Don't forget the guts. Not a lot we can do with that. 2 sine x cos x is the derivative. Y equals x cos 2x. That is a product. So I've got x times cos 2x. I have to use the product rule. So my derivative would be derivative of the first times the second plus the first derivative of the second. Okay, the derivative of cos is negative sine. Don't forget the guts. So I could tidy that a little bit to cos 2x, subtract 2x sine 2x. Next, we have y equals sine x plus cos x to the 4. So we have an expression in a power. So we're going to bring down the exponent, reduce it by 1. Also, don't forget the guts. So the guts would be the derivative of sine is cos. The derivative of cos is negative sine. So that is our derivative. Also, not a lot we can do with that to tidy up. Our last one is y equals sine x over cos x. So we have a quotient. So a derivative of sine x is cos x, so derivative of the top times the bottom, subtract the top, derivative of the bottom, all over the bottom squared. So to tidy that up a little bit, I've got cos squared x, I've got positive sine squared x, over cos squared x. And the beauty of this thing from our trig identities is that cos squared x plus sine squared x is always 1 over cos squared x. If you also know from your trig identity, the reciprocal of the cos is secant, so that is the secant squared. Lastly, if you know from your trig identities, is that y is actually the same as tan x. So just a side note, you don't need to use it, but if you have y equals tan x, its derivative is secant squared x.